So today we'll be talking about what data residency is, our journey to data residency at Atlassian, and then we'll jump a little bit more into what it means for us at Atlassian as well. I'll hand over to Jamie, and Jamie's going to deep dive into Easy Agile's data residency journey, the decisions that they had to make and while they explored their implementation, how it was implemented, and some of their learnings along that journey as well. Before we get started, quick show of hands. Who here has explored data residency or has had a look at what data residency is? Awesome, tons of hands, that's good. So, what is data residency? Well, generally, it's the ability or requirement or capability to store and process data within a specific region. In our context at Atlassian, data residency provides our customers control over where their data is stored, defining each region, or selecting that region where UGC is stored for each of their products. There are a few reasons that our customers may want to utilize this. The first one is clearly regulatory required customers. Financial industry, banking, healthcare, government. They'll face into highly regulated industries, regulatory requirements, obligations, which require that they store data within specific regions and locations. Secondary to that, contractual requirements. Some people have customers who are regulatory. They need to deliver and have data in one specific location to deliver their service to those customers. And finally, corporate policies. Some organizations have specific internal policies that define where their data is stored. So, what's data residency at Atlassian? Well, currently we have 6 regions, and we have over 1,000 customers every month who are pinning their product to one of those regions. Each time they do that, they are also looking at where their apps are stored. So they can see that their apps are pinned to those regions, where they can move their apps to those regions, or if their apps aren't able to be stored in those regions. So every single time one of those 1,000 customers is moving their product, they're also looking at where those apps are storing data. Today, we have 6 regions, 6 new regions coming soon. So we've got USA, Canada, Germany, EU, Europe, Singapore, and Australia. And shortly, we'll also support Japan, South Korea, India, United Kingdom, Brazil, and Switzerland. You can follow along more at the Atlassian Cloud Roadmap, but they will be coming within the next few months as well. So, at Atlassian, as we said, we provide customers control over where their Jira or Confluence data is stored. In these circumstances, we're talking about in-scope data. What's in-scope data? Well, at Atlassian, we have a clear definition of what is in-scope and out-of-scope for data residency. We store some data within those regions, and they can be pinned category, and there's data that isn't pinned or isn't stored within those categories. That may be for reasons of product analytics, performance, etc. But for us, it's important that we document and share this with our customers. Similarly, we only provide data residency for data that's at rest. It's important that each SaaS product or each app defines their own definition of what data residency is. It may look different for another online SaaS product. It may look different for another app. Every app should form its own clear definition of what data residency means for them and how data residency looks. And Jamie's going to look into that in a second and explain that. So it seems like a really good opportunity to hand over to you so you can talk a little bit more about what data residency means at Easy Agile. Thanks, Jamie.
So Easy Agile's journey to data residency sort of began in July of this year. And so far we've implemented realm pinning, and we're working towards releasing realm migrations in early next year. Just to give you some background, we've got 4 apps on the marketplace for Jira. Programs, Team Rhythm, Roadmaps, and Personas. And our first app, Team Rhythm, was formerly known as Story Maps, released in March of 2016. We have a couple of development teams at Easy Agile. We've got 2 development teams that look after 2 apps each. We've got an internal systems team that look after our website, our analytics, and our marketing data. And finally, a platform team who are responsible for our infrastructure, continuous integration and deployment pipelines, and security. And as Sean mentioned, my name is Jamie and I'm on the platform team at Easy Agile. Today I want to share about Connect Data Residency and why we chose to implement it at Easy Agile, how we went about the implementation, and the decisions and some of the complexities that we encountered. And I hope this helps you on your own journey towards data residency. Let's jump in and define Connect Data Residency quickly. Many of you are no doubt familiar with data residency, and here's a simple illustration demonstrating what Connect Data Residency means for us at Easy Agile. In this example, a customer's Jira instance is located in Australia, but Easy Agile's Connect data is located in the United States. And the separation of these data sources is the problem we're trying to solve with Connect Data Residency. We want to take our Easy Agile Connect data and bring it together in the same geographic location as the Jira instance data, with the end result being both data stores being located in the same geographic region. As Sean mentioned, this is important for customers in highly regulated industries. And so naturally adopting data residency at Easy Agile allows us to support those enterprise customers who have these regulatory and contractual requirements. Essentially, having data residency, in our opinion, is required to be considered a player in the enterprise market. Atlassian have also marketed data residency as a way to overcome many objections that enterprise customers have had concerning migration to the cloud. At Easy Agile, we want to ensure that customers take us on their cloud migration journey. And as such, we don't want data residency to be a factor when customers choose to take us on that journey. While matching Atlassian's objectives around data residency, we hope that customers would see our commitment to matching functionality and therefore continue to consider us a competitive solution to other providers. So once we decided to proceed with data residency, we knew there'd be several important decisions, many of which would be based on our customers, our application architecture, and how we could deliver value quickly. To understand some of the decisions we made, there's a need to understand how our applications are put together and how they are hosted in the Amazon Web Services. So here's a simple illustration of one of our Connect apps. For example, you can see the browser at the top here with roadmaps loaded in. So when the app loads, we pull our JavaScript bundles from CloudFront, so they're at Edge. And then obviously once the page loads, we connect to Jira and also to our Connect server, which is built into a container. So anyone familiar with Docker, we build our backend into a container so that we can host it in Elastic Cloud, Elastic Container Services in AWS. And obviously it's a Node.js server built on top of the Atlassian Connect Express framework. So this is what our Connect server was like before implementing data residency. On the left, there are Jira instances that are pinned to realms, so Germany, Ireland, United States. However, regardless of where the Jira instance is pinned, they all connect to our Connect server in the United States. And for us to implement data residency, we'd need to start storing customer data in the same region as Atlassian. And our first question was, what realms should we support? Should we support one realm, multiple realms, all realms? We weren't really sure. Neither were we sure about the ramifications of only supporting one realm or some realms. But we did analyze our marketplace data. We looked at our support requests, talked to our partners, and most of our customers were primarily located in two locations, the United States and Germany. And the United States is our default realm, so that's where all our infrastructure currently sits. So the obvious decision was to create a German realm, and that's what we intended to do, and that aligned with Atlassian's communications as to where clients were awaiting the release of data residency to migrate to cloud. So what data was in scope for us at Easy Agile? As you can see here, the diagram or our storage solution is pretty straightforward. We just have one database connected to our Connect server. We don't store other information like documents or things like that. So it's pretty straightforward in that respect. But yeah, it's where we store all our Easy Easy Agile specific data. So let me just clarify what I mean by that. For some of the functionality in our app, we can store information on a Jira issue, right, with entity properties, or on another entity type. However, our app provides specialized functionality. For example, we have a feature called retrospectives, which I'm sure many of you have heard of before. And what you can do is you just create like a retrospective page. You can add retrospective items, put them in columns like continue, stop, improve. So you can hold a retrospective ceremony, right? So, but there's no real nice place to store that information in Jira. So we store it in our own database in the Connect server. So when we consider data residency and our customer-specific data, our entire database becomes in scope for data residency. Now, Atlassian only requires us to implement data at rest. And what I mean by that is that that's data that's inactive, and it's not moving between devices or networks. It's essentially storage. However, for Easy Agile, we determined that implementing only data at rest would result in more internal complexity. We would have to configure our Connect service in the United States to manage connections in different locations or different realms, as per the diagram on the left here. Additionally, customers pinned to other realms would still be connecting to our application logic in the United States, which may impact our customers' user experience. So the alternative was to store and process our customers' data in the same realm. And we decided that that would be easier for us to implement, quicker for our customers, and potentially more secure. For example, we could take our existing infrastructure and replicate that in other regions to create a separation between realms. And that is what we intended to do. So with the region selected and our scope of data defined, we need to begin the implementation. And so if you take a look at Atlassian's documentation, you'll see that to implement Connect data residency, there are two capabilities that you must implement: realm pinning and realm migrations. And this separation that Atlassian provided was the perfect place for us to break our implementation and allow us to focus on delivering these two capabilities separately. We first deliver realm pinning in September, and after that we move on to realm migrations. So what this allowed us to do was that if we implemented realm pinning first, it would allow us to provide a new realm for new customers and any customers migrating from server DC. So in order to allow for migrating customers from server DC to actually migrate to our new German realm, we just had to implement the new migration URL in our app descriptor, which was pretty simple to do, and it enabled server customers to then migrate to the new realm. After we completed realm pinning, we then move on to realm migrations, and that would allow our existing customers to move from the global realm to our new pinned realm. So implementing realm pinning. As I said before, realm pinning allows new and migrating customers to pin marketplace apps to a realm. To implement realm pinning, you need to update your Connect app descriptor and add the region-based URL property with key value pairs for each realm that your product supports. In the Atlassian documentation, you can see an example of the new property in the app descriptor with key value pairs for all the currently supported Atlassian realms. What these key value pairs do is they tell Jira which Connect server to install to and use when a customer has a Jira instance that's pinned to a realm. So just recapping what our infrastructure looked like prior to data residency, and this is just for one of our apps, obviously. We only had one realm, and that was the United States, and all the pinned Jira instances were talked about one realm. After implementing a new realm for data residency, we ended up with two realms. Obviously, the United States realm was the same, and we had a new German realm for new customers to migrate to. So just to note, these are completely independent of one another in our implementation. They're actually in separate AWS accounts. And this is what our app descriptor looked like for Team Rhythm. We implemented the new Cloud App Migration webhook to allow migrating customers and we implemented the region-based URLs that pointed to our new infrastructure in the German region. And this is what it looks like from a customer perspective. This is actually our staging environment. You can see that the Jira instance is pinned to Germany, and you can see that the install apps here are also pinned to Germany. One thing to note is there's a Mario app there that's pinned to two locations, but I'll talk about that later. And so in mid-October, a couple of weeks late, we released realm pinning in Germany for our customers. And 6 weeks after release, this is how many installs or customers using our German resources. So moving on to realm migrations. Realm migrations allow customers that are currently pinned to a realm or in the default realm to migrate or move to another realm. In Easy Agile's context, this means that our existing cloud customers could pin their Jira instance to Germany and then request a migration of their Easy Agile specific data to a German realm. And based on the data in scope that we discussed earlier, we'd need to extract all the information for a customer from our global realm and then move that over to our German Connect server database through some migration infrastructure. The migration process is actually initiated by Atlassian's migration service, which communicates with our global Connect server to tell us that a migration needs to take place. So just to go into the implementation, the Atlassian documentation indicates that for realm migrations, apps need to update their app descriptor with a DARE migration URL path. That's the top box there. And the path on the Connect server is expected to receive and respond to 5 webhooks that indicate the different stages of migration. The schedule, indicating that a customer has scheduled a migration. Start, begin the process of migrating a customer's data. Status, provide the current status of the migration. Commit, the data should be ready to be used at commit. When we were first thinking about this, we were thinking about commit as in terms of a transaction in a database, having it ready and then doing commit. But in this context, commit is actually the data should be present and ready to go. The other one here is rollback, which something went wrong. Customer data should not be migrated. If it's started, then any changes should be rolled back. As mentioned in the documentation, these webhooks come from a new service, but they use the same JWT authentication method as in the Connect server. So our implementation of realm migrations uses Lambda, API gateways, and AWS Batch to provide a serverless approach to migrations. I don't have time to go into why we chose Lambda, why we chose gateways and the other AWS services, but if you're interested, come and talk to me later. So this is a sequence diagram that only shows part of the start webhook process that we've been implementing at Easy Agile. Our approach has been to try and create a migration infrastructure that leverages our current app containers and reduces our infrastructure costs by removing the need for a constantly running migration service. So I've explained the diagram from left to right. The yellow circle at the top is the Atlassian migration service where a request is sent to our Connect server, start webhook, in the source realm. And in this diagram, the source realm is our United States global realm. The request is then proxied from our Connect server with some additional information to a Lambda function via a private API gateway. The Lambda function creates a migration record in a DynamoDB table and then starts an AWS batch task. This AWS batch task runs the extraction logic using the container, our Connect server container, to extract the customer information from the Connect server database in our United States realm. Once that's complete, Batch notifies the Lambda via the event bridge, and the Lambda then sends a request to our Connect server in Germany to start the ingestion process. And the same process essentially takes place in the German side of things. The Lambda updates the migration record, triggers the ingestion task using the container, triggers the ingestion task and starts the AWS batch task that uses the container to ingest the information in the Connect service database. And finally, updating the migration record when it's ready to commit. So some of the advantages that we've tried to, or we've found, or we think are here in this implementation, is that we're able to reuse our app containers, right? So when we build our Connect server, we build a container, right? We've got a certain entry point in that spins up the Node.js process, and obviously that becomes the Connect server. But by leveraging that container and using a different entry point, we can then run a different process in that same container and utilize all the libraries and data access layer that we have in our Connect server. With a serverless approach, we don't have a migration service constantly running, hence reducing our costs. And we don't need to give our developers access to our Connect server database. So by storing the migration data outside in a DynamoDB, our developers can look at the migration process, or we can log that out, and therefore we don't need to give access to our Connect server's database, and obviously that's important for things like SOC 2 and ISO and security. Our infrastructure design also allows us to scale across applications without specific infrastructure for each app. So because the ingestion and extraction processes are in the containers, each app can implement their own ingestion and extraction, so it's scalable across all our apps. So we're hoping to release this early next year. So after implementing realm pinning and working through realm migrations, we've found some tools to be really helpful. I'd like to share about 3 of these that have been super helpful for us. Mario, our private Connect app, using infrastructure as code and having a pipeline library that we can use for our CI/CD pipelines across all our apps. So I said we have 4 marketplace apps, but essentially we have 5, and our 5th app is a private test app called Mario. Mario is essentially set up with the same architecture and infrastructure, replicating the basic functionality and structure that's common to all our apps. Mario has allowed us to test each part of our data residency solution to date. And the first thing we did was we updated Mario's CI/CD pipeline to be able to deploy our regional infrastructure, or to be able to deploy the Connect server to our regional infrastructure to test that our workflows worked in both staging and production without impacting our app teams. Secondly, Mario allowed us to test and validate our changes to our app descriptor, allowing us to install Mario in our Jira staging environment pinned to Germany. And this also allowed us to test realm pinning and realm migrations without releasing it to our customers. Here's something similar to before. This is just Mario's app descriptor, and you can see there's an extra one here, but yeah, same as before. And this is what it looks like in the staging. Mario also helped us test our infrastructure, allowing us to validate that our infrastructure permissions, logging, and compliance monitors are all working as expected. This is Mario's UI. You can see there's a couple of things here. There's some bug snag tests and some migration webhooks. So we've set Mario up for us to be able to simulate Atlassian's migration service. So we can come in here and just click start, status, commit, or rollback, and it just does an end-to-end process of our migration process, so we can validate that. So where we're up to at the moment is we've done our end-to-end. We've got tracer bullets all the way through, and we're in the process of working through our ingestion and extraction tasks, and we're hoping to abstract that away so that app developers really just need to work with the data and not worry about like AWS specific things. I can't overstate how much Mario has helped us in identifying and mitigating issues throughout the implementation of data residency. I would definitely recommend using a private app if you've got the time to set one up. Aside from Mario, we leaned heavily into infrastructure as a code. In fact, all our regional infrastructure is defined in the AWS CDK in TypeScript and is deployable from the command line using the AWS CDK CLI. Additionally, we use the CDK to create our own classes and constructs that allow us to embed our default implementation requirements. To give you an example, you can take like an S3 bucket. You can create your own secure S3 bucket, and you can by default enforce SSL, encryption, block public access, And then when you use that in your infrastructure code, you know that that bucket's secure by default. Having infrastructure defined as code has allowed us to define and capture all of our infrastructure in a repository, allows us to comment on it, and we can deploy it quickly. We've also utilized our CI/CD pipeline in the repository to actually run a synth of the changes. So when we do our PR process, we can actually look at what's going to change in the infrastructure before it gets merged. By codifying our infrastructure, we know that our current and future infrastructure deployments will be consistent. They're all deployed using the same code. And finally, having infrastructure as a code, we believe will allow us to deploy a new role in a couple of days, much quicker than doing it manually. Here's just a quick example of a CDK app that deploys some of our Connect infrastructure. You can see the app is constructed at the top. There's a couple of app-specific settings here, some tags, and then you can see here there's the Connect stack and the Connect app. And when I say stack, it's essentially a CloudFormation stack, but it's wrapped obviously in the CDK and in TypeScript. The third aspect that really helped us was in our continuous integration and delivery pipeline for our apps. We utilize internal repositories in GitHub, and that's been allowed us to write internal actions. So I don't know if you use GitHub or not, but most of the actions out there are public. We wanted to have private ones, so we're able to utilize our internal repositories to do that. But this has meant we have consistency in all our deployment pipelines, making it easier to understand and work on as a team. Having separate actions within an internal library allows us to keep our deployment actions separate from the application repositories and reduces the need for our, when we make changes to impact our product teams. The other advantage that we found is that we can update our CI/CD pipeline pretty easily by just releasing patch versions and minor versions, and that's based on how the GitHub Action versioning works, and that allows us to put changes through without requiring a pull request in the application repositories. So finally, I just want to touch on some of the complexities we've encountered while doing data residency. Coming back to which realms to support, this will be an ongoing question for us at Easy Agile as Atlassian releases more realms. We need to consider our customers' needs, along with the additional cost of each region that we want to support. For us, there is an additional cost. Obviously, doing data at rest and also processing in realm, there is an additional cost for us. And we don't expect there'll be any increase in revenue other than any new prospects that we've gained by supporting data residency. So at this stage, we've only rolled out one realm, but we're working with our customer experience team to determine what realm is next. I suspect it might be Australia, but we'll see. Related to what realm to support, we've also considered reusing our infrastructure for multiple realms. So we initially thought we could take our German infrastructure and reuse that for the EU realm. However, we haven't done this yet because there's no real way for us to determine which customers are pinned to which Atlassian realm. So if we wanted to provide a separate EU realm in the future, we'd have no mechanism to move customers out of our German infrastructure into our new EU infrastructure. We also considered the same option for our global realm, using it as a pinnable United States realm. However, if we did do that, we'd have to make sure that we implemented all the data residency requirements for a global realm. And that might limit our future flexibility, but it's still something worth thinking about. So combining regions was our initial intention. However, we put that on hold for the moment. So there are some potential consequences for not installing or not supporting all realms. An edge case recently captured by Atlassian related to uninstalling and reinstalling apps in a data residency context. For example, if one of our clients was pinned to Germany and then migrated their instance to the EU, we don't support an EU realm at the moment. And if the Jira administrator then uninstalled and reinstalled the application, it's possible that the reinstalled application would be located down a global realm, not in the German realm. And if that were to occur, our clients would not see any of their Easy Agile specific data. And so they'd be connected to our global realm, but their data would still be persisted in the German realm. And so they would need to reach out manually via a support request, and we'd need to manually migrate their data back to the global realm. And Atlassian's working on a realm persistence period after install to reduce the risk of this occurrence. We're looking forward to seeing that. And to date, we have not encountered this situation. So we haven't released migrations yet, but we have identified that some of our existing data schemas might present a challenge when moving between databases. This is due to our auto-generated IDs and foreign keys. For example, an auto-generated ID in the source database might already be used for a different client in the target database, and that would result in a collision when the migration took place. To resolve this, the team has a couple of options. They could replace the auto-generated IDs with something like a UUID, a unique identifier, or we can process the associated records in the Connect server's business logic when migrating from one realm to another. As I mentioned before, our global realm is in the United States, and at the moment we don't want to deploy more infrastructure to provide a United States pinnable realm. As such, there's not really a good way to communicate this to our customers. For example, our customers will see our Easy Agile apps as ineligible to migrate to the United States at the moment because we don't have that pinnable realm. We're still working on the best way to communicate this with our customer experience team, and at the moment we've just included the United States in the privacy and security tab on the marketplace. Hopefully they'll reach out and go, well, it's not pinnable, and we can explain why. It's because the default region is the United States. So Atlassian and the team, Sean included, has provided fantastic support to Easy Agile, always answering questions. It's been fantastic. By the way, if you're not aware, Atlassian does provide a cloud premium instance to test and validate your data residency implementation, and you can just reach out to support and they'll get that set up for you. Just going to hand it back over to Sean.
Thanks, Jamie. Cool. So I'm conscious we've been talking about data residency for Connect. Quick update, you would have heard yesterday as well. So data residency for Forge hosted storage is coming soon, and it will allow partners to offer data residency for all data their apps store within that hosted service, without making additional investments in implementing or maintaining realm pinning or migration for it. If you are eligible to participate in the upcoming EAP, we'll reach out to you directly, and this will be available for a few select customers. More broadly, we plan to enable data residency in beta for customers, with self-service data residency beginning in the first half of 2024. Thanks everyone for listening.